All right, welcome back to my graphs. So now we're going to take a look at our graphs. We are still in the 9-7. These notes are a little lengthy just because, like I said, they're very content heavy. They give good examples. I like the longer notes just because it lets you see the better representations here. So we're going to get into some stuff. So if we're looking at this one, I'm going to pay attention to this really big thing here at the top. These look like, oh my gosh, it's such a drastic difference. Oh, that's not that bad. Well, the difference is this graph starts at 0 and this one starts at 10. They are skewing this on purpose, so they broke the graph. To skew the data. Have to be careful with that. That looks drastic, that not so much. Okay, so now let's look at this next one. So our second example. Well, our second example here is talking about just the number of adult frogs in the South Pond. Okay, well, you're like, whoa, there's like so many more adult frogs in the South Pond. Oh my gosh, it's drastic. Only because they're using the bigger frog. So if we're looking at the frogs, well, this big frog is just representing 3 of the small frogs. They just use that to let you know, oh my gosh, wow. You're like, oh my gosh, that's great. September has so much more. Either one doesn't make a difference. These here represent the same. So these are the same. They just made this one bigger to be more dramatic. To draw your eye. Okay. All right, but the height of this is the same as the height of this. That doesn't change. Okay, so now let's look at our number 3 here. So we're looking at a histogram. Well, look, there's this tiny little outlier over here. It's not really a part of the data. This is like the exception and the rest would be the rule. So when you look at the numbers, you want to make sure if they're including that when they're making their calculations. But this is what the graph would look like. This would, if you include this, then it says, oh my gosh, your graph is skewed all the way to the left. But if they don't include this, then your graph is pretty standard. Okay, the big one that we want to make sure we pay attention to, and I know this is hard to read because it's not in color, so I'll give you your values here. The apples here are 30, the cherries here are 20, and the lemons and limes are going to be 40.5. I know it's hard to read. That one's 25, that one's 34.5. But the key point in this is we need to make sure that all these percents need to total that magic number of 100. Has to. If it doesn't, why are they leaving something out? So that's going to be how you look at those graphs and how you can play those out to say, oh, okay, this is what they're trying to do to me looking at this data. So this is all just a physical representation of what we were talking about down here when we're talking about graphically what we're looking at. All right, so with that being considered, let's take a look at the very last part of this. So when you're talking about research methods, these are the key questions that you want to make sure that you're asking whenever you're looking at a set of data. You want to make sure that you can say, hey, well, what is it that this data is trying to say to me? What is it that they are trying to construe? So these are the key questions I'm going to ask myself. So before trusting any information that's being represented to me, we want to make sure that in general, we want to never fully trust what we see. That's just saying, hey, maybe they're trying to get something out of me. Maybe they wanted to lean in their favor. Those are things that we want to consider whenever we're looking at data, because you want to know what the person is aiming to construe as far as their idea set. So that wraps up 9-7, and I hope your projects go well.